We're on.
Hello, Mr. Stone here, and we're going to do a little bit of review of the law of sines. Now, the triangles that we're working with, these are non-right triangles. This can work with right triangles too, but right now, if you need to know an angle measure or a side of a non-right triangle, where there are no right angles in there, the law of sines is going to be our tool of choice. So the way you would set this up, each point, each vertex of the triangle, we can give a letter A, B, and C, and we're going to use capitals for those because that's a good common naming convention. And it's convenient that the opposite side, so the opposite side of our capital A or big A here, is this little a. Okay? Opposite of this big B is this little b. Opposite of our big C is little c. Okay? So that relationship is concrete, and the beauty of the law of sines is that we've got a common ratio. So if you've got the sine of A, whatever this angle measure is here, you take the angle measure of this, and you divide it by its opposite side, little a, it's going to be the same thing as if we take the angle measure of big B and divide it by little b, its opposite side. Okay? And the same thing, sine of the big C divided by little c, they're all going to be equal to each other. Sine of big A over little a is the same thing. It's equal to sine of big B over little b, which is equal to sine of big C over little c. This magic of how this works allows us to figure out a triangle if we've got certain given information. So let's take a look at this one first. We're given two angle measures here. A is 20 degrees. And angle C is 30 degrees. We've got one side here, which this is across from C, so let's call this little c. So little c is going to equal 12. Let's say we want to find little b, or excuse me, little a. It's across from A. Since we know one angle and the side that's across from it, that allows us basically to solve the whole thing. So let's set it up. We're going to do sine of big C, because we know big C, over its opposite, little c. This is going to equal the sine of big A over little a. Now we plug in. We know, we chose the C because we know it. So C is 30 degrees, so we have the sine of 30. And remember, you can only take the sine of an angle. You cannot take the sine of sides. So we're taking the sine of big C of the angle. Sine of 30 over its opposite side, 12, is going to equal the sine of, we're using big A, so we're plugging in, sine of 20 over little a. We don't know little a, but we can figure it out. This all of a sudden just becomes like this super accessible algebra equation. We want to get a isolated by itself. So for starters, let's multiply both sides by a. We've got to keep them even, right? That means that a is going to cancel out on the right. We also want to get rid of this 12 in the denominator on the left side. So we're going to multiply both sides by 12. Got to keep it even. The 12 on the left cancels out, so we're left with a times the sine of 30 equals 12 times the sine of 20. We want to get a by itself. We divide both sides by the sine of 30. These cancel on the left, and we're left with a equals 12 times the sine of 20 over the sine of 30. That's it. This is your answer. You plug this into your calculator, and you should get 12 times the sine of 20 divided by the sine of 30. 8.2. That's how we would use the law of sines to find a sine. We can also use it to find an angle. So in this case, we've got, let's identify these. Across from big C, this would be our little c. Little c equals 9. Across from big A, we've got little a. Little a equals 12. And we've got the measure of angle, big A, which is 70. Again, we're going to set a ratio. In this case, we're using A and C again. So the sine of big A over little a is equal to sine of big C over little c. Plug in what we know. So the sine of, this is 70 over, we're plugging in here, we're just plugging in. We don't know this big C, so we're going to leave that the sine of big C, but we do know its opposite side, which is 9. All I've been doing is just plugging in right here. I'm just taking information here, putting it here. And again, now we've pretty much got an algebra equation that is very accessible. In this case, though, we only want to get sine of C by itself. So we can multiply both sides by 9. We just clear out this denominator, and we're pretty well set. So these cancel. We get 9 times the sine of 70 over 12 equals sine of C. Now we've got to go one step further that takes us a little bit beyond our algebra. In this case, we've got to undo this sine. And to do that, we're going to take the inverse sine of both sides. And this is on your TI-84 calculator. Do second sine, and you will be able to plug in whatever you get for your answer here. So I take 9 times the sine of 70, divide that by 12. That gives me something here about 0.7048 approximately. I take the inverse sine of that, second sine, and what my answer was, and that gives me 44.8. So this 44.8, it's actually degrees, and that is what my C is. So that's it. When you're given certain information, you're able just to plug it into the equation. As long as you know our wonderful, beautiful, amazing law of sines, you can set up equations to solve given the information that we've got there. Okay, practice this a bit. It is super accessible. Let me know if you have questions, and be awesome.